Okay, so here I have a fancier exponential equation than we've seen currently, where I have a fraction in the base and a fraction in the power. And if you can't see that, I'll just write it down here also. It says y equals, let's use a better color. That's not a better color. Try again. There we go. A, some starting amount, times the base 1/2, and it has to be in parentheses because it's a fraction. It's got two pieces. And the power is x divided by what I'm calling HL. And this HL right here is what we call half-life. And half-life is used a lot in the medical profession when they're talking about how does a certain substance leave your body, like alcohol, like a certain drug, like maybe a sedative, or something like acetaminophen. I exercise a fair amount, and sometimes I overdo it, and occasionally I get aches and pains because of that, and I might take acetaminophen or I might take ibuprofen. I drink coffee sometimes, and coffee is a stimulant. How long does that stimulant last? Well, it turns out a lot of these substances in our body are filtered out, and the way those filters work is the body removes like roughly half at a time. So it turns out like caffeine up here has a half-life of about 5.5 hours. So what that means is if I make a table here, time versus caffeine, initially I have 100 milligrams in my system, right? Big stimulant. And then the half-life of 5.5 hours means exactly 5.5 hours later, I have half of what I started with. So now I only have 50 milligrams. Another 5.5 hours later, so that would be 11 hours later, I have half of that 50 or 25 milligrams. Another 5.5 hours, so that would be 16.5 hours later, I have half of that, which would be 12.5 milligrams. And so many substances work this way in our body with the way our blood filters stuff out, okay? Or the other organs help filter stuff out of the blood, I should say. So here I'm giving you information about the half-life of caffeine and a starting amount. Now I used 100 here because it was easier. My version of the problem starts with 115. Yours will be slightly different. So if I take these two pieces of information here and here, then my equation would look like this. That A gets replaced, that's the starting amount, the 115, kind of like a starting population or the initial value of a car. And then I multiply that by 1/2 in parentheses, and then the power, I'm going to put that in parentheses just to be safe, would be x over, and for mine it was 5.5. So that's my formula right there. So sometimes in situations where things grow or decrease, we're given a percent change, but other times half-life is a popular way to talk about these kinds of changes. So this is still an exponential equation, it's just a little different than the ones we've seen before. Okay. So what I want to do is I want to go over with you how to make sure we get this into the calculator right and see if we can solve this equation. It's going to be a little harder than the last couple that we solved, but not too much. So the first part here just asked me to state the equation. Here they switched a couple things up on me. Instead of a y, they want me to use a c. And instead of an x, they want me to use a t. So I have to make sure I get that right. So in my little box, I would say, okay, c equals 115 times, parentheses are necessary here, 1/2. And then it's going to be raised to the power, and we probably don't need it for the power, but I'm going to put it there anyway, parentheses, x over 5.5. Oh, nope, they said to use a t. And the cool thing about the computer is if you put the wrong variable in, it'll say over here, wrong variable. Pay attention to those. Sometimes I forget to read the fine print. And then the first question just says, hey, plug in 10 and see what happens. So let's all try my equation on the calculator and see if we can agree on what the answer is. Well, we're going to plug in t equals 10 for the power. I'm going to go to my calculator. And the Desmos calculator is pretty nice, or you could use whatever calculator you have nearby. Desmos. All right, so mine starts at 115, and then I multiply by parentheses 1 over 2, and it makes a nice pretty fraction. Oops, if I could type correctly. 1, there we go, over 2. Oh, come on, Desmos, get down there. And then I want to raise that to the power, and this one is going to be 10 over 5.5. And when I enter it into my calculator, I want to make sure that whole fraction is in the power. And Desmos is telling me with those numbers, it should be 32.6 roughly. So please make sure that you can make your calculator come up with the same number, that you got parentheses in the right spot. So I'm going to double check this in my Google calculator where parentheses are going to be needed more. So every calculator works a little bit different. Google requires, or an Android calculator is pretty similar to this. And then that would be 10 over 5.5, close parentheses. And Google agrees with Desmos, about 32.6. So after 10 hours, this equation says you'll have about 32.6 milligrams. In the question, let's see, do I have it open here? I don't. Anyway, that's okay. Where's my notebook? There it is. Yeah, so I think 1 milligram is probably close enough. So if you're not sure, we could go 32.61, and then yours will be a little bit different. Here's the harder part, question C. I have to figure out how long, I have to solve for T for 20 milligrams. So that's going to be the tough part. Oops. New page, there we go. So my equation now looks like C equals 115, parentheses 1/2, raised to the power T over 5.5. And then I was told, when is the caffeine going to be equal to, let's see, what was mine, 20 milligrams? Oops, wrong page. Back here. 20 milligrams. So that means I have to set these two equal. So now I get 115, and it doesn't matter what side you write it on, to the T over 5.5 equals 20. So based on the problems we just solved, what do we do first to solve this one? Any suggestions?
Would we divide by 115?
Yeah, excellent. We divide by the 115. Yeah, because that's the furthest thing away from T. So I'm going to divide by the 115. And then that cleans up. The 115 is divided out. So now I have 1/2 in parentheses to the power T over 5.5 equals this fraction. And you could turn it into a decimal, but then you have to keep track of all the decimal places. So usually what I do is I just leave it as a fraction. If the fraction freaks you out, then go to your calculator and change it to a decimal. So that's your call. So you could take the 20, divide it by 115, and then decide how many decimal places you want to keep. And in an intermediate rounding step like that, I would keep at least 6 to be safe, which you can do if the fractions freak you out. But I'm going to stick with the fraction there. I'm going to keep it as 20 over 115. All right, what should we do next? We've got everything away from the base. It's now logarithm time. So the next step here, since I have the base alone, is to take the logarithm of each side. And I'm just using square parentheses just to differentiate because I have another set right there. Okay, so the rule of logarithms, once I get to this point, is that the power, the whole power hops out. The power is the T over 5.5. So that whole chunk pops out front. So next, I get T over 5.5 times the log of 1/2 is equal to the log of 20 over 115, or maybe you wrote the decimal version of that down. Okay. So far it's not too much different than what we've done before, except we got a crazier power. So we have more fractions to hang out with here. At this point, there's a couple of things you could do to solve. In the last set of problems, we divided by the log first. So I could do that next. I could divide by the log of 1/2 here. Get that over to this side. And remember, the logs don't cancel. We're stuck with them. All right, so the log of 1/2 divided out. So now all I have on this side is t over 5.5. What do you think the last step's going to be? Anybody? How about we multiply by 5.5? And that gets the t all by itself. And then this is what I would need to plug into my calculator to see if I got it right. So I'm going to do that next. So I had the log of 20 over 115, which I chose to hang on to. You may have a decimal there. That has to get divided by the log. Make sure we close parentheses in the right spot of 1/2. Close parentheses, super important. And then I can multiply by the 5.5. So according to Google, it's almost 14 hours, 13.88 hours. Desmos should give the same answer if I enter it right. So with Desmos, I got to go over to the function to find the log. If you're on the web version, calculator version looks a little bit different. And then I can take my 20 over 115, get out of the denominator, close the parentheses, divide by the other log. So a few more buttons to push here. Get out of the denominator, close the parentheses, get out of the denominator again to multiply by 5.5. So again, we have to master our own calculators, and Desmos agrees with what Google had, about 13.88 hours. All right, well, I said I would let you guys out early, but I lied. I'm so sorry, I didn't mean to lie. All right, so we can either quit here or you guys can hang out for one more example. Your call. Suggestions? Looks like it is mostly depart then. If you want to see one more question, let me know. I'll do one more. Still with me, Alejandra? Or are you heading out?
Yeah, I'm heading out, sorry.
Okay, that's all right. Have a great day. It's good to see you today.
You too, bye-bye.
Okay, bye, Alejandra.